Okay, the mechanical coupling is just for hybrid vehicles. Okay, this mechanical coupling, its mainly function is to distribute the torque from different inputs and outputs. Which are our inputs and our outputs? Well, the power that the engine or the electric motor could give us in order to move the vehicle. Okay, it can transmit torque to the transmission using the electric motor and conversely deliver torque to the electric motor by reverse charging the battery by means the genetic braking. Okay, so here it is the mechanical torquing. For example, if we want to move the vehicle with the engine, well, the engine is gonna provide us the mechanical torque. The mechanical torque is gonna go to the mechanical transmission, and we're gonna be able to move the vehicle. So the same with the battery, no? The battery is gonna supply the inverter, the high volt, the electrical motor, and the motor is gonna move the mechanical coupler and the transmission. Okay, I'm gonna move the vehicle. But at the same time, with this mechanical coupler, if we provide power from the motor and at the same time with the engine, we're gonna have more power and we're gonna have more power to move the vehicles. And another case, with the engine, you got supply torque, mechanical power, and this mechanical power could move the motor that it could works like a generator and can recharge the high voltage battery. Okay, so the mechanical coupling is very important to the powertrain. Okay, but it's just for hybrid vehicles. Then, guys, we are gonna talk about in this point the supercapacitors. What is a supercapacitors? Well, supercapacitors is another storage system. Okay, as the high voltage battery, well, the supercapacitor have the characteristic of storage electricity. Okay, let's see. Supercapacitors, energy storage system that supplies a lot of energy in a small period of time. Okay, so it's like the cells, but it works in a different way. Okay, let's see his advantages and disadvantages. In the advantages, we have well, it have low impedance, so they can receive or give the power more instant. Okay, they are very high specific power, approx 3 kilowatts, 3 kilowatts per kilogram. So it's very high specific power. So what does it mean? They they are very small and they could storage a lot of energy. Okay, good performance in low temperatures. Okay, good performance in low temperatures. Uh, so they will have the good performance in low temperatures. Well, supercapacitors also can work in low temperatures as different of the high voltage batteries. No, the high voltage battery. Well, the chemical of the high voltage battery don't work in good conditions in low temperatures. The supercapacitors don't have this problem. Okay, they are very fast charge and discharge rates. So why do we have this? Because they can receive a lot of amounts of power. Okay, and they don't have a degradation inside. So it's very good advantages and the durability. No, a big difference of the supercapacitors with the high voltage or lithium-ion batteries is that the lithium-ion batteries have a cycles life, no? After a amount of cycles, of charge discharge cycles, well, we are gonna aging our battery and the battery is gonna dead. Well, the supercapacitors don't have cycles times. So you can charge and discharge all the times that you want, okay? But they have a period of life. Imagine that they say, well, the period of life of this capacitor is 10 years. In these 10 years, you can make all the charge discharge that you want. Okay, that's very good advantages. But let's talk about the disadvantages. low per cell voltage. Okay, so we are gonna need too much supercapacitors in order to create a 400 system. Okay, so it's gonna be very expensive also. Then high decrease of their voltage as they discharge their storage energy. Okay, so uh, as they receive very quickly the energy, also they are gonna discharge very quickly. Okay, not sustainable for AC circuits to their fast working times. Okay, you cannot work. Uh, you cannot supply AC circuits with the supercapacitors. Okay, it's just for DC circuits. Okay, and so it's very useful the technology. Okay, in heavy duty vehicles, but la they cannot use it for all the perform of the vehicle because, as I say, they discharge very quickly. Okay. Applications, a big power supply in a small period of time, no, because they are gonna discharge very quickly. So it's big power supply in a small period of time. High energy storage from a low power source. Okay, uh, and reliable temporary power source. Okay, so you could go with your pass, for example, no, and recharge the vehicle with the pantographer, and you're gonna recharge the supercapacitors, no, and then with the supercapacitors, you're gonna move the vehicle, and after you discharge completely your supercapacitors, you're gonna start to use your high voltage battery, no? It's the you need a combination of your battery plus your supercapacitors. Okay, supercapacitors eliminate the instantaneous energy demands based on batteries, preventing the batteries declining capacity. Okay, as I say, is you need very amount well a lot instantaneous energy demand for moving the vehicle, for breaking the inertia. Okay, so if you use the supercapacitors, it's gonna be better for the state of health of your battery. Okay, then the designs of a hybrid energy storage system can be optimized to prevent battery oversizing for power demands. No, so as I can say, you can use the supercapacitors and the batteries. So you are not gonna need big batteries or too much capacity of battery because you can play with these two energy storage systems. Okay, so when you have these two energy storage system, well, the supercapacitor is gonna need a DC-DC converter because, as I say in the last slide, the supercapacitor has low amounts of voltage, so probably it's around the 200. You are gonna need the DC-DC converter to boost the voltage to the 400 volts. Okay, so you are gonna have the battery and the 400 volts in order to supply the e-power train. Okay. And finally, guys, let's see an example of a drivetrain components layout. Okay.